Okay, now we're going to start solving these word problems, or sorry, solving these exponential problems. We're going to be able to solve problems that have variables as powers. Now there's two main ways to go about this, although they kind of break off into separate branches. The first way is called common base. Now this is the one that's kind of a special case. It only works in a few cases. But if the numbers that are being brought to the powers can be expressed as a power of the same number, in this case 27 is really 3 to the third. If they can be expressed as a power of the same number, of the same base, if they have a common base, you can just get that common base, simplify, so right now these powers would multiply, and then drop your bases. You get 3x equals x plus 1, subtract an x from both sides, so 2x equals 1, so x equals 1/2. Basically, the point is, if this statement is true, the only way that 3 to the 3x can equal 3 to the x plus 1 is if the powers themselves are actually equal to each other. And so we're basically logically saying, okay, if 3 to the 3x equals 3 to the x plus 1, we don't need the bases of 3. We can just compare the powers and solve from there. And you can check these all really easily. I'll just do 27 to the 1/2. 5.196, and I'll do 3 to the 1/2 plus 1. And do the same thing. So I solved it. So here, 16 is a power of 4. But if I wanted to, I probably shouldn't have written this problem this way. In fact, I'll change it. Let's take this 4 and let's make it a 32. So ignore this. Yeah. 32 is not a power of 16. 16 squared does not give you 32. But 32 is 2 to the 5th. And 16 is 2 to the 4th. So they are still both powers. They do have a common base, just the base is 2. So both of these get sent down to their lowest base. Well, they multiply the powers, I'll get 2 to the 5x equals 2 to the 4x minus 8. I have to distribute that 4 to the x minus 2. So really 5x must equal 4x minus 8. So x equals negative 8 if I subtract the 4x from both sides. Solving the common base is pretty straightforward. What's better is to use logs. Problems like this are ones we've been working our way towards solving for quite a while. One way to solve a problem like this is to convert to log form. Right now it's an exponential form, so if I convert, it would be log base 5 of 0.4 equals x. And from here I can do the change of base formula. Remember, the change of base formula said this: log base b of a is equal to log a divided by log b. And what's nice about this is it's in base 10. I had a base 5 logarithm originally, but now I can do it in base 10, log 0.4 divided by log 5. And we get negative 0.56. And I can check that. If I do 5 to the previous answer, I get out 0.4. So 5 to the negative 0.56932 is 0.4. Here, I want to get the exponent all by itself. So I'll add a 2 to both sides, and I get 3 times 8x to the 8x plus 1 equals 18. Divide everything by 3, and 8 to the x plus 1 equals 6. Now, I could again take a log of both, or take it into log form. If I wanted to go into log form, that would look like this: log base 8 of 6 equals x plus 1. I would then calculate that, log 6 divided by log 8. And whatever that number is, subtract a 1 from it. Log 6 divided by log 8. What's that? Minus 1. And my answer would be negative 0.13. I say about equal to because we're rounding. But another option, one that some people prefer, especially if you're not very fond of converting, is to instead take a logarithm of both sides. And I literally just put the word log in front. You only want to do this once you're down to just the exponential part of the problem. I still have to get rid of the 3 and still have to get rid of the addition subtraction up here. I want to get down to just the exponential part of the problem. But it's the same logic as before. The only way that this can be true is if this is also true. And what's handy about this is we have that property of logs, the most useful property of logs really, that lets me take powers and pull them out in front. So this becomes x plus 1 times log 8, and that equals log 6. Then the x plus 1 has to be in parentheses because you're multiplying the whole thing by that. So now I would solve. Divide both sides by log 8. Then you'd get x plus 1 equals log 6 over log 8. Subtract the 1. That's an arrow. And look, these two things are the same. It actually ends up being the exact same method. They just look a little bit different in the start. So now we can solve worthwhile problems like this one. You have $45,000 earning 3.2% interest compounded monthly. How long until your account has a value of $25,000? Well, we're doing this formula. Sometimes the y is an A for amount. P is your principal, P stands for your starting amount, but A or Y is your final amount. We are trying to figure out how long it takes us to get to 25,000. We're starting with 4,500. We're earning 3.2% compounded monthly, and the question is, how long will it take? 12x or 12t. T stands for time, x and t can be the same. Well, I need to simplify this down as far as I can. So the first thing I'm going to do is divide everything by 4,500. I can also calculate the value inside the square root also. So 25,000 divided by 4,500. It's going to be 5.5 repeating. And I'll calculate that number inside the square root also. 1 plus 0.032 divided by 12. 1.0026 repeating. And this is now just another logarithm problem, another exponential problem like we've been doing. I've got everything down to just the base and what it's equal to. If I wanted to convert this into log form would look like this. Log base 1.0026 repeating of 5.5 repeating equals 12x. And then I can do the change of base formula. Log of 5.5 repeating divided by the log of 1.0026 repeating equals 12x. And then I would divide all of that by 12 or multiply it by 1/12. I guess I'll calculate this first. I'll do the log of 5.5 repeating, so I'll just type in a bunch of 5s just to save some time. Put down a lot of 5s. Divided by the log of, in this case, this is my previous answer, so divided by the log of my previous answer, and I get 643.9. So now I divide everything by 12. And it's going to be about 53 years. And that's a totally fine way of handling that. That's how I usually do it, is by converting into log form. But the other option is to go into take a log of both sides. So from this point here, we can also take a log of both sides and say the log of 5.5 repeating is equal to the log of 1.0026 to the 12x. And with our property of logs, this can come out in front. Sometimes it's nice to have parentheses around these to kind of split up what the log is a part of and what the log isn't a part of. So I could have done all this up here if I'd wanted to. And get that x by itself. So divide both sides by 12 times the log of 1.0026 repeating. And again, you'll note how similar these two things look because they're basically the same. When I type this one in, it's going to be a little bit more rounded because I can't type in the decimals perfectly so easily. But I'll do the log of 5 point a bunch of 5s divided by, in parentheses, that's very important. If you're going to divide by all this at once, put it in parentheses. 12 times the log of 1.002 with a bunch of 6s. And we get 53.65 again. So very, very similar. That is solving exponentials. You use your logs. Thank you all. Have a nice day.